Hi, welcome to How to Repair. In this video I'll be explaining how to dismantle a gas burner top or gas stove top hob and how it comes apart and how each individual component works. Basically, it doesn't matter if you're on bottled gas or natural gas. The principles are all the same, and whether it's a countertop or a freestanding appliance, the principles are the same. Your gas comes in via a rail, 2 gas valves. This will depend on how many burners you have on your appliance. It is then either got an ignition system, which is a manual button that you press, or you will have each individual switches like this one, which are activated when you turn the knob on, and you will hear the clicking sound and the spark lights. These valves then regulate the amount of gas going through to the burner cup. The burner cup not only has a small jet in it, depending on the size of the burner and also depending on the actual gas that is going to the appliance. The gas on natural will be a bigger jet than the gas on bottle. The gas on bottle would be a smaller jet. This then is actually controlled and made safe via the FSD system, Flame Safety Device. It basically is 3 components. You have your gas valve, which is manually operated. You press the button down, the spark is generated, and this will allow, while pressed down, gas to flow to the actual head. If you take your hand off before the actual thermocouple gets to temperature, the gas will go out. The thermocouple generates a small amount of millivoltage electricity when heated. This is from the Seebeck effect, which was invented in 1800s. Basically, you have 2 dissimilar metals on the tip which generate a small amount of electricity that holds the actual gas safety device open once it's at the correct temperature, meaning that you can remove your hand from the knob and the gas will stay lit. If the wind blew the flame out, for example, or you had a spillage, the tip will cool, therefore not producing any electricity, therefore shutting the gas supply off on the valve, making the appliance safe. Let's go through how the whole system works, and I will also be showing you how the igniter system works as well, which is called a spark generator, which goes through to an electrode, which basically generates a spark at the actual burner cup to light the gas in the first place. Before we start, I have to do a disclaimer. All gas appliances should be worked on with someone that is qualified with gas. Safety is an important factor. In the United Kingdom, gas needs to be worked on by gas safe engineers, and this will vary around the world. So, first thing we need to do is take the griddles off, and these can go to one side. Then we need to take the burner caps and tops off, or burner heads as known. This then will expose some screws. Now, this is a new appliance and I can't emphasize this enough. These screws can become very, very sticky to undo on used appliances. This is because they're going into an aluminium cup, and the screw is steel or stainless steel, and sometimes they can corrode because dissimilar metals can cause electrolysis, which makes the threads very stiff. So whenever undoing these, I always suggest using the correct piece for the actual screw type, and not only do it up a little touch, I mean literally a little bit, then undo, then do up, then undo, then do up. This will free the thread at no end, and you might have to use WD-40. Before starting to do this, I always suggest you turn the gas off to the appliance and the electricity as well. So I will quickly undo these. Then you need to actually remove the knobs. Now, on some appliances, you may have to go underneath the appliance to actually remove any mounting bolts, but this one just comes away, and be careful not to damage the electrodes. Okay, the first thing we're going to deal with is the ignition system. Now, this will vary from appliance manufacturer to appliance manufacturer. On some appliances, you may just have an ignition button that you press when you turn a gas valve on. But since 2008-2009, there's been a lot of increases with safety systems put on appliances. Now, this appliance here has got what you call a wiring loom going through to the generator, which is on the appliance. Now, you have 240 volts coming through to the actual spark generator. One side will be the live, one side will be the neutral. Now, basically, this is an open circuit without the knobs being pressed down. When the knobs are pressed down to ignite the gas, it then creates a circuit. Once a circuit is created, the actual electrodes then will have high voltage electricity going through to them to actually ignite the gas. This is what happens, and the clicking sound that you can hear. And this will actually be sending the electricity through the actual electrode to the actual burner cap. And the electrode just sits in like that, and you can see the spark being generated. Now, faults that can occur with certain burners not lighting and others lighting may be down to either a defective electrode. As you can see with this one, it's got a break in it, and the electricity, as you can see here, is conducting through to the burner cup or burner head, not the burner cap. This is generating a bad spark which is not igniting the gas correctly. Now, another fault that can occur, you may have badly insulated wires due to the wires degrading over a period of time, or possibly getting a fracture in them and going through to the actual chassis of the appliance. This means that the electricity going to the actual head of the electrode is not getting there at any strength, and therefore not igniting the gas. You may also have a problem with the actual terminal that connects to the spark generator. As you can see on the screen here, the actual spark is shorting against the chassis. This usually can be rectified very easily with heat shrink over the actual terminal to make sure it's fully insulated before it goes along its journey to the electrode cap. Now, another problem that can occur is conductivity. The actual top of the appliance is grounded to the actual earthing system on the actual appliance via the screws that go through to the burner cups, which I showed you when I was dismantling the actual hob. Now, if there is a build-up of fat in that area underneath the burner cap, between the actual space here, this then can actually create a bad circuit, meaning that the spark is unable to jump between positive and negative. This would also cause a problem with the gas not lighting. Another common problem that a lot of people have sent in to me is they have intermittent clicking noises. This means that the spark is being generated when people are not wanting it. In other words, the gas may be already lit, but the spark is continuing to be generated. This is usually down to bad switching. Spillages and water getting onto these switches, either in the loom or near the generator, can cause the switches to be active when they shouldn't be. And this can cause intermittent faults with spark igniting systems coming on when they shouldn't be, and you may just be getting a click occasionally, or multiple clicks occasionally, or a consistent click. This can easily be rectified with maintenance. In other words, making sure that your spillages are mopped up and the switch system is cleaned out and made sure that they're not active when they don't need to be. As you can see on this system that I've got here, I'm just going to rest this down, we have individual switches on each valve. This is a 5 burner. Now, this is an open circuit when the appliance is not being used. But when you press this down, it activates the switch, which then makes a circuit to the spark generator to activate the generator to send the spark to the system. And you can check all this with a multimeter. Okay, for demonstration purposes, and you should only do this if you're competent with electrics, this spark generator here, which is off a 240 volt appliance and will vary around the world, whether you're on 120, 220 or 240. This actual spark generator has a live and neutral connected, which is normally connected to the loom, which I'll test in a second to show you how to test that. But basically, once power is introduced to the spark generator, it then sends electricity through to the electrode, which I've put here on the actual chassis, to show you that the spark is being created. So if you turned a knob on, it would actually activate the spark generator. And by connecting the spark generator directly to 240, you can actually hear the spark constantly sending down each one to the electrodes. And I'm keeping my fingers away because it's quite a nasty shock if you do get one. But basically you could see that jumping a spark across onto the actual chassis. Okay, testing your ignition circuit is quite easy. You basically have a live, a neutral, and an earth coming through to the appliance. make sure it is disconnected from the electricity supply before actually doing anything. Then disconnect the wire that comes through from the actual entrance into the appliance, which is the neutral, and then disconnect the other wire from the spark generator. This then has a series of switches, and using a multimeter and just putting one terminal on each, we have no continuity. This means that the circuit is good but untested. Now when we press down any of the knobs, we should have continuity. This would allow the actual neutral wire to actually activate the spark generator, because the live wire is actually already going to the spark generator, and you are able to test each individual one that it's generating actually the electrical circuit to activate the spark generator. Now if you have intermittent clicking sound, I suspect that you have either a fat residue build up in the switches or possibly a short on one of the switches, which is actually creating a circuit to the spark generator when you don't want one. And this is why you would have an intermittent clicking sound coming through to the actual burner. The spark generator normally has stamped on it whether the voltage and the supply. This is a 240 volt spark generator which has a live and neutral connected to it. If you connected a circuit to the live and neutral, therefore you would hear it clicking constantly and sending sparks to the actual electrodes. Okay, now we've dealt with the ignition system and we know we've got a good spark on each of the units. We now need to go through the components on the gas. Firstly, you have your gas cap. This can be called different names by different manufacturers. Then you have the gas head. This is what distributes the gas around to create the nice flame that you have. It also allows gas to flow immediately through to the ignition system, which then lights the gas. On some of these units, there may be a hole built into it that can get blocked. And you'll see on the screen here, you only need to clear the hole to allow the gas to flow through to the actual ignition system. Underneath this, you have the gas cup. Now the gas cup actually consists of the thermocouple, the ignition system which is bolted onto the side, and also in the middle you may have one or multiple jets in different positions depending on the type of burner that you have. These jets can become blocked. The idea of the jet is basically to control a flow of gas which will mix with a certain amount of oxygen to create the perfect burn flame. In other words, the clear blue flame that you can see on the screen here. Now, if a jet is blocked or worn, it may cause the actual flame to be discoloured or not very large. And I'll show you later how to clear these jets. Very simple process. Now, going to the thermocouple. The thermocouple is a safety device that was introduced around 2008-2009 with all gas appliances with regards keeping the flame lit. But if the wind blew out the flame, therefore the thermocouple would stop producing electricity, which controls the thermoelectric device or solenoid. This solenoid only needs a small amount of DC electricity to stay open. Now, when you actually press your hand down on the actual gas knob, you hold it down for 5 seconds, or 10 seconds, depending on the hob you have, and the flame stays lit. But if the gas is blown out by the wind, this little device attached to the thermocouple will cool. Once it stops producing electricity, you will hear a click and the gas will stop coming through. There you have it. And I'll be showing you later how these things work, because this was actually invented in the 1800s, and it's basically the Seebeck effect. And this is what two dissimilar metals, they can vary in the type of material that they are, which is produced by the manufacturers, which creates a small amount of electricity that actually keeps this solenoid open. Now, the way that this all works is the gas valve, when you override the system by pressing down the knob and turning it onto the gas supply, will then allow gas to go through and ignite at the burner head. Once the actual thermocouple produces a certain amount of electricity, that little solenoid which you saw then will actually stay open. And as the heat on the thermocouple keeps producing electricity, this will stay open. But if the wind blew it out, therefore it would shut and make your gas appliance safe. and we'll go into all these components, how to maintain them, and also how to actually test the individual thermocouples as well. And I'll be showing you inside the valve on how the actual valve works. Clearing a gas burner that is not burning correctly or not actually maintaining a good flame is a very easy process. You have the burner cap. This needs to be cleaned up and kept clean because the actual electrode, it sends a spark to this to ignite the flame. If this is greasy and dirty, it will not make a good spark. Underneath here you have the gas head. Now the gas head, as you can see, has many distribution points around it to actually allow the gas flame to burn correctly. But if these are dirty or blocked, then the flame pattern will not be correct. There is also a passageway through to the electrode, which actually allows gas to go through here quickly to ignite the gas. If this is dirty, or on some models you have a little hole inside here, these can block and not actually ignite well because the gas head is not maintained and cleaned. You need to actually clean this in hot soapy water, and you can use a brush or a scourer to clean this, but I would not use any toxic material as this is aluminium. Underneath here you have the actual gas jet, or you may have multiple gas jets. These gas jets need to actually be kept clean. They can block due to corrosion in the pipes as it gets old, or spillage can actually build up inside the jet. Now to remove these are normally a 7mm, and you're able to take the gas jet out. You can then actually take the jet out, and you need to clean it in hot soapy water, and you can remove with a very small item or a gas cleaner. They do actual specific gas jet cleaners to a specific size of the hole. This one is a 0.72 size. Now we don't want to actually press hard, we just want to remove any dirt that's in here. Once you know this is perfectly clear, then you need to insert the gas jet back in. But what I would always suggest you do is turn the gas on first, just for a quick second, to blow any debris that may be in there. And that wasn't meant to happen, a spark generated. But that now is clear, and we can now insert the gas jet again. Reinsert the jet, but make sure you do not cross-thread it. Once the jet's inserted, you can reassemble the burner head and burner cap after you've cleaned it. Then the appliance will light and you will end up with a good flame pattern. If you have some yellowing appearing, just give the cap a tap, and this will actually settle the cap on top of the head correctly so that you have a good burn pattern. Okay, I thought I'd show you how the whole thermocouple and the thermoelectric device works, or the solenoid. I've actually dissected a valve for you so you can actually see the valve in position here. Now if I undo this a second, take the valve out, you can see the gas flows through here, and there is the actual orifice that goes through to the actual head, and this sits in here. Now when you actually press the knob in, you can see it's mechanically overriding. This is because inside here there is a pin that comes out and pushes the actual valve down. And what actually happens is once the valve's down, it creates, the thermocouple creates a certain amount of electricity, somewhere between 10 and 30 millivolts DC. So at the moment I've got this thermocouple, spare one, connected to my multimeter, and we're going to turn the gas on. You can actually see the voltage now coming through on the multimeter, and this will get to the point where the valve would automatically stay open. Now once this flame has been reached to the maximum temperature, and this is because of the positioning of the thermocouple, we have a constant voltage of 16 volts, and this is what keeps the valve open. But if the actual gas was turned, the gas was turned off and the flame is off, you can see the voltage now dissipate. And once it got to a preset voltage of whatever the actual solenoid is designed to stay open, then of course the valve would flick open and shut down. Now let me show you this with the actual valve in place. Okay, I've actually inserted the valve now into the electrical side of the thermocouple, and I have the thermocouple set in front of the flame. Now, if I press the valve down now, you can see it will not stay shut. But if I light the heat and let the thermocouple get to the right temperature, and when I press the valve down, it will stay shut. But if I turn the gas off, after a preset time, if you watch the end of the valve here, as the thermocouple cools down, not producing electricity, it shuts the valve off. Thank you very much indeed for watching the video. It took us a long time to produce this one as it was quite complicated, and I'm sorry the length of the video is so long, but if you're doing a job, it needs to be done correctly, and understanding how all the components work is an important factor to diagnosing problems. Whatever part you're looking for on your gas appliance, remember two things. You need your full model number and serial number on many occasions. These can be found on gas worktops underneath the appliance, but you may need to take the oven out to get access to this label. On freestanding appliances, the label is either on the back of the appliance or sometimes in the door on the framework. I'd like to thank RDS International for supplying us these appliances for us to make videos for you. And I'd also like to let you know that we've put a link in the description below to a page which will assist you in finding all the correct component names and also identifying the correct part for your appliance. Thanks very much indeed for watching, and if we really helped you, you can always click on the Bipolar Beer page to donate to the website. Thanks again for watching.
RDS International is leading the way in environmental responsibility, exclusively serving trade customers, businesses and shops. We're committed to ensuring white goods don't end up in landfills. Operating throughout the UK, we strictly adhere to the WEEE directive, guaranteeing that appliances are disposed of in compliance with regulations. Beyond mere disposal, we breathe new life into refrigeration units by repurposing them for developing nations. And a special note for our trade partners: for every load we dispose of on your behalf, we pledge to plant a tree, ensuring it springs to life. Our primary objectives are distinct: to protect our environment, support global communities, and address Europe's escalating white goods dilemma, all while adding a touch of green.